If you like this content, please consider clicking on the like button. It lets me know what content you like, so I can focus on that. Please also consider subscribing if you find these videos educational and entertaining. Numbering systems and bases. The term decimal means base 10. This is what we all grew up learning. It is used because we have 10 digits on our hands, and the first people to count used their hands to represent quantities. Base 10 goes from 0 to 9. This is an important part of a base numbering system. It goes from 0 to 1 minus the base. For base 10, that is 9. Once we have used all the digits in a column, we overflow to the next column to the left. For base 10, we call the first column the ones column and the second column the tens column, and so on. Mathematically, each column from right to left represents a power of that base. The first column is considered the base, 10 in this case, raised to the 0 power. Anything raised to the 0 power is 1. This is the multiple for values in this column. So, if we have a 3 in the first column, it means 3 times 10 raised to the 0 power, or 3 times 1, which is simply the number itself. We don't often include this, since anything multiplied by 1 is itself, but I think it is important to understand the pattern here. Let's say we have a 4 in the second column. This means that we have 4 times 10, raised to the first power. This is 4 times 10, which is 40. This result is added to the value from the first column to give us the answer, 43. Now, let's think about a different base, specifically 16. Base 16 is also called hexadecimal. We count from 0 through 15. Remember, we never get to the base, only one less than the base. Now you might say, how can we do that? Digits go from 0 to 9. We must have additional symbols for the remaining numbers beyond 9. We need symbols that can be used to represent numbers beyond 9, so we use the letters A, B, C, D, E, and F. These represents the decimal numbers 10, 11, 12, 13, 14, and 15 respectively. When we get to 15, we're going to reset our current column and increment the next column to the left. Going to the math of this, each column from right to left represents ever-increasing values of powers of 16. The first column represents 16 raised to the 0 power, or simply the number times 1, or just the number. The second column to the left represents that number times 16 raised to the first power, or 16. So if we have a number 3 in the second column, it is 16 raised to the first power, or 16, times 3, or 48. Computers know about zeros and ones. This is called base 2, or binary. It follows the same pattern as with other bases. We have only two values, 0 and 1. And as soon as our column is filled up with 1, it has to spill over to the next column to the left, for the next bit. Each column, from right to left, represents 2, raised to the power of that column, starting with 0. So, the rightmost column represents 2, raised to the 0 power, or 1, times whatever is in this column. The second column to the left represents 2 raised to the first power, or 2 itself, times whatever is in that column. And in this way, we can represent with 8 bits, 2 raised to the power of 8, or 256 unique values. We call 8 bits a byte. This is the fundamental unit of data in a computer system. This is important. 1 byte can have 256 possible unique values, from 0 up through 255. Now with base 10 and base 2, they are not easily related. It is hard to derive simple mathematical relationships between 2 and 10. As humans, we like to think in base 10. Computers only think of data in binary. Computer data in base 2 and hexadecimal in base 16 are mathematically related. 16 is 2 raised to the 4th power. So a single hexadecimal digit, also known as a hex digit, can hold 4 binary digits, also known as bits. Since a byte has 8 bits of data, it follows that with 2 hex digits, we can represent a byte worth of data. Let us work through an example. We will decode the hex digits E, F, using what we have learned so far. F, in the far right column, represents the value itself. In decimal, this represents 15. In binary it is 1, 1, 1, 1. The E, in the second column to the left, represents the value, times 16, raised to the 1st power, or 14, times 16, or 224. In binary it is 1, 1, 1, 0. Combined, this number represents 224, plus 15, or 239. In binary it is 1, 1, 1, 0, 1, 1, 1, 1.